For this portion of the tutorial, I'll be demonstrating how to make the master rod in CATIA. Before starting anything in CATIA, one must first check the units. Under Options and Parameters and Measure, you can make sure we're using the appropriate units for the part that we are constructing. In this case, we want millimeters. Going under Mechanical Design and looking at Sketcher, we can create a spacing that we so desire. How to make the master rod. First, create a new part. Enter the YZ plane. We're going to create the profile sketch. Using the arc command and align, you can create an arc with a diameter of 35 millimeters or 17.5 radius, constraining it so that the end as follows is 9 millimeters from the line, and also from the end of a line that's connected to the arc is 13 millimeters from the bottom line. This radius will be made into a reference element later. For now, it will be used to create the part. Make a circle tangent and coincident with the line as follows, the point being coincident and the line being tangent, using constraints defined. The circle has a dimension, as noted, 72 millimeters. Circle with the same dimensions will be constrained coincident with the line, and the circumference of the circle will be made coincident with the point at the end of the line. Circle with a radius of 13 millimeters we made tangent to the 72 millimeter circle as follows. We made tangent to the other one. The step will be continued, repeated for another circle. So the circle is also 13 radius. Create vertical and horizontal constraints between the 13 radius circle and also the line. Now, distance between the outer radius 13 circle and this point of origin of the arc at 289 millimeters. By moving around, we can see it's properly constrained. However, you can see right here, it is not fully constrained, so there must be one more constraint met. Making that a length will ensure that that 17.5 radius arc stays constant. Exit out of Sketcher, pad 35 millimeters. This will be 1/4 of the part. Create a fillet of radius 35, selecting the appropriate line. Now mirror this portion as follows. Choosing the Hole command, select the appropriate surface. Choose the specified diameter and enter into the sketch portion of hole definition. using equidistant at point, center the point between the two lines as shown. Now place a reference point concentric with the arc as shown. This point will serve as a dimensioning tool. However, this point will be later removed. Directly constrain the point to the object as shown. The step you have seen is to ensure that there is no conflicts. Reference points in sketches will often lead to complications. Selecting the appropriate surface and a corresponding arc, and using the hole command will center the hole appropriately. Simply just choose the appropriate dimension for the hole. That previous hole was 24 millimeters. The one before that was 52 millimeters in diameter. The hole you're seeing that was just created was 10 millimeters in diameter. The sketch that was just completed with the points placed concentric to the arcs as shown will represent the user pattern to replicate the hole with a diameter of 10 millimeters. Exit Sketcher. Select the hole that you would like to replicate using user pattern and selecting the sketch. You can now place the other 10 millimeter diameter holes. Selecting the front face, a cutout will be made. Placing a circle concentric with the left side circle with a diameter as shown, diameter of 63 millimeters. Project 3 elements of the surface. Now with this sketch you can pocket to the dimension in the diagram. Enter the back face and place another circle concentric using two circles. Constrain as follows using coincidence and tangencies. Repeat on both sides. After doing so, use Project 3D Elements, selecting the appropriate faces. Using the Erase command, remove undesired lines. Exit out of Sketcher once again, and pocket to the specified depth. Enter into the top surface once again. What will be created now is the elongated hole. Under the square command, there is the elongated hole command. Change the radius as follows to 6 millimeters. For ease, create a point concentric to the right circle. Dimension 30 millimeters away from the center of the right side radius. Now, place another constraint as follows, deleting the previous constraint that conflicts. Carrying out this process of constraining into the object itself as opposed to a point that's a reference point that's constrained to the object will resolve issues later on. Pocket to the appropriate depth. Now, selecting the following face create an offset plane that's 6 millimeters away from the surface. This plane will be centered. Choosing this plane, create the following profile. This profile will set up a groove, creating the detailed section of the main part. Using the arc command and the line command, as well as spline commands, constrain. Choosing to do a groove like this saves a multitude of steps and will lead to an approximate looking part. There will be a radius present. There will be an insignificant curvature looking down from the top on this part. Choosing the groove command and the appropriate axis, the detail was created. Then using the mirror command, the rear half of the part was created. Reflecting the piece like this causes the YZ plane to intercept halfway through your part. Going back into the profile sketch and moving it in this manner will test how accurate the part is and how well constrained it is. The part successfully updated without any problems. The part is now complete.